So hopefully you understood the first three just by looking at the slides. I'm going to give the answers here to the second three, that second set here. Okay. Again, it's without logarithms. You may find logarithms easier in the long run after you do a few more of these. Let's start with what I think is the easiest one, 3 to the 2x equals 9. And why I think that's the easiest one is because I know I need a base of 3. And I can pretty confidently say, okay, 3 times 3 is 9, so 3 squared. 3 squared is equal to 9. Okay? And I need to use 3 because there's my base of 3 there, so I need this to be 3 to some exponent. And that's why it's limiting, because it may not exist like we like it. But in this case it does. Base 3, I can ignore the bases and say the only way the left side equals the right side is if 2x equals 2. If 2x equals 2, we would divide both sides by 2 and x would equal 1. Okay. Now that one's pretty straightforward because we all kind of know that 3 squared is 9, so that works out nicely. Okay. Let's look at these ones. Okay. We probably don't know that 5 to the 4th is 625. Okay. Probably not something we just walk around with in our head. But the reality is 5 times 5 times 5 times 5, 5 to the 4th equals 625. Okay. Now to solve these without logarithms, we can only give you equations where you can find 5 to some exponent equaling that, which means we're very limited into the numbers we can use here, but they're numbers that work in this case. Okay. So that would mean the 5's get ignored. 7x equals 4, right? The 5's don't get canceled, they get ignored because we know they're the same. And then x equals 4 over 7, okay? 4 over 7. We'll do the last one. Do the last one. Okay. Again, 64 needs to be 4 to the exponent, something that we can handle. Okay? And it is. It's 4 to the 3. Okay? Then I know these look slick when they work. Okay? So here we go. We ignore the 4's and make the exponents equal to each other. And then we solve that little equation. I need to bring 3 to the other side and add it. 2x is going to equal 3 plus 3, which is 6. And then I'm going to divide by, I'm going to divide by 2. So x is going to equal 3. Right? X is going to equal 3. Okay. And it works, right? So you get an answer for all of these. Okay. Now, before I leave this, I'm going to go back to this one. What happens if that's a 10? Okay. What if I've changed that to a 10? Well, the problem is, how do I get this as 3 to some exponent? Because I don't know what that exponent is. It's not 3 squared, because 3 squared is 9. It's not 3 cubed, because 3 cubed is 27. So it's going to be like 3 to the exponent 2.07, I don't know, something. I'm just kind of making that up. I know it's between 2 and 3, but I can't get that, so I cannot use this method of solving it. And this is where you need to get into logarithms. Okay. What if this is 3? What if this is 12? Okay. Still, 3 to what exponent equals 12? Well, 3 to the 2 is 9. And 3 to the 3 is 27. So this exponent, 3 to what equals 12, would have to be between 2 and 3. And it's a number that we can't get properly, but it's a number that we will be able to get going forward here using logarithms. So we'll see in a slide or two, we'll get back to logarithms and how it's much more useful than a format like this.